Good afternoon and welcome to my laboratory. What you're looking at there is a Laser Saber Jewel Thief variant powering two neon ring oscillators. The Laser Saber Jewel Thief variant is in the center there, and it's being powered from the regulated 5-volt output of the trusty dusty L&Co precision regulated power supply over there. That goes down there and then back up there. And that's what's powering the Jewel Thief variant. And the Jewel Thief variant is running both of those ring oscillators. Okay, and here is the schematic and some notes. For the Jewel Thief variant, and I'm using a 2N3055 there, and a ferrite bead for the center core of the toroid. All right, and here is the schematic for the ring oscillators. You got a full wave bridge and some capacitors and the neons and then the dropping resistors, and that's all there is. There's the component values down there. So the resistors are 220K, quarter watt, and the capacitors in my unit here are 1 farad or 1.0 microfarad 250 volt polyfilm caps. Okay, and then this 220 microfarad cap here, this one, is a filter reservoir cap for the ring oscillator. It's just over here because that's a convenient place to put it, or for the bridge rectifier rather, excuse me. Okay, so that's the schematic for both of these ring oscillators. The reason the flashing pattern is different is because of the arrangement of the wiring of the capacitors. This one is hooked up in a circle, and so it's flashing in a star pattern. This one is hooked up in a star, so it's flashing in a circular pattern. Got that? Very simple. Okay. What I mean is, if you wire it just exactly like this and ring it all around, it will flash like this. But if you switch the connections of the neon to the capacitors in a logical way, it'll flash like this. Okay, so now what I'm going to do, what I have here, this is a giant ping pong ball. Actually, it's a normal size ping pong ball, and I have a little piezo speaker element there. It's already had some damage chipped off of it, but these are pretty easy to work with and they're cheap. And I cut a slot, and this ping pong ball is just an acoustic resonator, so I cut a slot in there, and I'm putting the piezo element into the ping pong ball to make it louder. And then I have that hooked up through these little jumper leads to some clips. And what I'm going to do is probe in the circuit with the piezo element as a probe. So let's just hang that up there. And then here's its input leads. So what do you think will happen? I'm going to use, I'll just put it across the output of the Jewel Thief very carefully because it's high voltage. And I don't know if you can hear that or not, but that's a very high-pitched audio squeal. Let me see if I can actually hook that in so it'll stay on. Might be able to. That's the collector side, and then that's the other side there. Okay, so that's a very high-pitched squeal, and I think you can see that the ring oscillators have died, takes them a moment or two to die because of that reservoir capacitor, but they do eventually die. So all of the output power of the Joule Thief is going to the piezo element in that case. Alright. Now the piezo element also acts as a capacitor. They have a few picofarads of capacitance, in addition to being a diode and also a vibrating circuit element. Okay, so now I'm going to probe around in the ring oscillator. Here. Just turn that over so it'll... I'll leave it up like this, why not? Alright. So if I hook it across the input, just the input to the ring oscillator, that'll be the same thing as we heard before, right? I hear a little harmonic in there now. Okay. And now what I'm going to do is hook it across one of those 220K I'll hook it across one of the capacitors first, and nothing happens. I just hear a little bit of clicking from the thing when I first hook it up, but there's no drain on anything and no behavior changes. Now I'm going to hook it across one of the 220K resistors. What do you think is going to happen? Think about it for a minute. Remember the circuit that I showed you. Try to predict what will happen when I hook this across one of those 220K resistors. Alright, so just as a review, I'm going to hook the piezo element across one of these resistors right here. This surprised the heck out of me. You see what's going on there? It's pretty loud too. Those neons are occasionally flashing bright blue. The one that's closest to the one that's actually on the resistor I hooked up is kind of flashing normally, but a little bit brighter than usual. And these others are just going crazy. And that's the part that I don't get, is why the behavior should change. Why does I don't know, interruption rate or whatever you want to call it, why does the beat of the piezo element change like that? And why do the neons flash in that brilliant manner when they do? Blue, they flash. Now incidentally, that's actually the same behavior that you get if you simply hook the piezo element directly across one of the neons, like that. Almost the same, but even weirder, really. Okay, that's driving everybody crazy. Enough of that. Thank you for watching.